Good morning to one and all. I am Karapanasamy, Assistant Professor EC, KSR College of Engineering. Today we are going to discuss about embedded systems. What is meant by embedded system? It is actually an electronic device which is used to perform a specific function. Or it can also be defined as it is a combination of hardware and software which is used to perform a specific function. So on in both the way it can be defined. And what is mean by firmware? If you are studying about this uh, embedded system, you should know what is meant by firmware. Actually, the software which is loaded into the hardware is called as firmware, and one of the most important task or characteristics of this embedded system is it gives the output within the time limits. That is very important to note down it here, and it can also be used for performing both simple as well as complex devices. And this is the simple block diagram of the embedded system. It accepts the input variables and produces the output variables, and it can also be used to connect with the other interfaces, other user interfaces. And also this embedded system or embedded computer can be connected with other system also. So this is the general block diagram. So this is the embedded system, contains both the hardware and software. So in next slide we will see what are the building blocks inside of this hardware and software, that is in the embedded system. So these are the main building blocks inside of this embedded system. Actually we have seen this block diagram. It contains the input variables and output variables. So see here. So these green blocks contains these embedded blocks. Okay. So these are the building blocks inside of this embedded, that is in the hardware and software. For example, that block consists of the processor, program memory and data memory, serial communication ports, parallel ports, interrupt controller and timers. So these are the main building blocks inside of this. In addition to that, it have power supply and oscillator circuits, and there is a system application specific circuits. It is also available in this. In addition to that, it has input devices and output interfacing circuits. So these are the main building blocks inside of that. We will see one by one what are the functions of these things, right? So, and this is totally called as embedded system. So here it has the system core, memory, input output ports. So that is the input ports may be a sensor and any other input device which may be connected to the system, and output ports may be can be, that is the output of this core can be given to the actuator, or some other communication interfaces can be given. So this is the general block diagram of this embedded system. Okay, or the output of this system core can be connected to support other devices, or other subsystem can be connected with that. This is the general embedded system. And the next one is what is embedded hardware. Okay, so this embedded hardware is a platform to perform a specific operations. Okay, or hardware of the embedded system can be assembled using the microprocessor or microcontroller. So basically the microprocessor or microcontroller is part of this embedded system. So without this processor or controller we are not able to do anything. Okay, so it has the number of elements, that is IO interfaces, memory, user interfaces and display units. So these are the main building blocks inside of that. Generally the embedded system consists of the following components, that is power supply, memory, processor, timers, input output circuits, serial communication ports and system application specific circuits. So these are the building blocks we have seen in this diagram. Okay, so these are the blocks we have seen. So these are the main components which are used in the embedded system. Okay, so then what is mean by embedded software, system software? Actually, the software of an embedded system is written to execute a particular function. Okay, so it is normally written in any high level languages. For example, using C or C++ you can write, and it can be compiled to offer a code that can be stuck within a non-volatile memory. That is, you can write the code using any high level language such as C, C++ or Java, and it can be embedded or it can be loaded into the non-volatile memory. Okay, so then the software is intended to keep in view of the following three limits. That is, when you are using this embedded system software, it has three limits. So what are those three limits? First of all, the convenience of system memory. So system memory should be convenient for performing or loading the software. I already we have seen what is meant by firmware. A software which is loaded into the hardware is called as firmware. So when you are loading the system software into that hardware, the memory should be convenient for you, right? And the processor speed. The processor speed also should be considered while taking into account. And then the next one is that the power dissipation also should be considered while designing an embedded system. Okay, so these are all very important while choosing this embedded system software. Guys, compulsorily you should consider the memory as well as the power processor. So then, what are the applications which can be used in this embedded systems? Okay, which can be performed using this embedded systems. Mainly, today this embedded system is used in automobiles, which is used to perform the motor control, cruise control, body safety, energy safety or engine safety, and robotics in assembly line, or multimedia, car entertainment, e-com, etc. can be performed using this. So today, the automotive embedded systems are highly important and most commonly used techniques. Maximum of the automobiles industries are using this embedded system for performing their applications. And in telecommunication also we are using these applications, that is, it includes networking, mobile computing and wireless communication, etc. So in embedded systems can also be used in smart cards, for example in banking. So you all know in ATM cards we are having the smart cards. It is also an embedded system. So it actually what are the operations to be performed as written as code, right? And it is loaded in that smart card. Based on that information loaded, it will be operated. So, and then satellite and missile also we are using for defense communication and aerospace. Most commonly we are using these embedded systems, and also in computer networking and peripherals we are using these embedded systems. Okay, so then digital consumer electronics, most commonly we are using, you know that. So DVDs or set-top boxes or high definition televisions or digital cameras, and most of the components what we are using in our home is embedded product. You know that our washing machine is an embedded product. Okay, so these are all some of the applications of an embedded system. So in various fields we are using these embedded systems today. Every one of you knows that. And the classification of an embedded system. So this embedded system is classified into three mainly: a small scale embedded system, medium scale embedded system and sophisticated embedded system. So we will see what are the difference between these three classifications. Okay, small scale embedded system means it uses an 8-bit or 16-bit microcontroller. The complexity of that hardware and software is little hardware complexity, and this may be a battery operated, and most commonly used system for developing the software is C language. Most commonly used language is C. And another thing you should consider while using this small scale embedded system is a need to limit the power dissipation when the system is running continuously, because it is battery operated. So because of this, it should be considered, that is, power dissipation also should be considered while designing a small scale embedded system. The programming tools which are used for performing this embedded system is editor, assembler or cross assembler can be used. And the next one is that medium scale embedded system. So it uses the 16-bit or 32-bit microcontroller, or DSP process can also be used, or RISC instruction set, that is reduced instruction set computer. RISC process can also be used for performing these medium scale embedded systems, and the complexity of both the hardware and software is high, and the programming tools which are used for performing this medium scale embedded system is RTOS source code engineering tool, or simulator, debugger, and IDE. So you know that today we are most commonly using the Arduino IDE or AVR, that is AVR Studio, are using for performing these applications. And the next one is the sophisticated embedded system. So compared to those two previous types, this is has enormous hardware and software complexity, and it needs a scalable process or configurable process for performing a specific task. You know that it is sophisticated. So based on that sophisticated, it may require a scalable process or configurable process based on its requirements, and the processing speed also should be considered while designing the hardware units, and the programming tools sometimes may not be sufficient or readily available for these type of sophisticated embedded systems. So it should be designed for specifically for performing these applications. Okay, so these are the things we have discussed today. So in next session we will see the remaining. Thank you.